So today what I want us to focus on is more specifically some special types of ionic compounds. So today I want to dive into deeper types of ionic compounds. I want to talk about two cases of ionic compounds. So you could title these notes Ionic Compounds, two additional concepts. Good. The first concept that I want to go over is naming ionic compounds with polyatomic ions. Now before we do that though, can someone remind me what an ionic compound will always contain?
No.
Okay, at least for sure, we know that it's going to be ionic because it is most likely containing a metal. And I'm going to add an addition now, or polyatomic ions. And do you know what a polyatomic ion is? What you just wrote down. Those are all polyatomic ions. So if you see a metal, or if you see one of these, what type of compound do you have? Guaranteed an ionic compound. Good? We know the rules for ionic use crisscross. There's no problem with that. So what I want to do for our two additional concepts is I want to talk about the first additional concept. So additional concept 1. Ionic compounds with polyatomic ions. So let me go over some rules, some things that we need to remember for these things, for these additional compounds. For sure, we still use crisscross. Remember, we're crisscrossing the charges. The new thing, though, that would go along with this is that now we're concerned about using parentheses around a polyatomic ion. And you know what those are, right? You just wrote them down. We use parentheses around a polyatomic ion when we have more than one of that polyatomic ion. More than one of that polyatomic ion. With this right through here, let me show you an example. Sodium sulfate. Can someone tell me what sodium is from the periodic table? And what's its charge? Okay. And from your listing, sulfate, what is it? It's SO4, right? And what's its charge? 2 minus. Do you know where I got SO4 2 minus from? Your notes, right? You just copy that down. I'm going to bring a 1 to down there. Is everyone paying very close attention? I'm bringing my 1 from the sodium to this location and bringing the 2 to this location, which we've done countless times before. Now we're just doing it with polyatomic ions. Good? So this should read Na2 SO4. Remember, do we write ones when we bring them down on ionic compounds? No. And so we would not use parentheses around the SO4 because the previous rule says we use parentheses around a polyatomic ion when we have more than one of it. Did we have more than one of the sulfate? No, because we only brought down a 1. Let's look at another example.
So if it was one with like +2 charge,
It would. Yes. I'll show you that right now. Calcium hydroxide, if you'll write that down real quick. What's the charge of calcium? Ca2 plus. And hydroxide is OH, and it's a 1 minus, correct? So we bring our charges down. The 2, it comes down. And the 1, it comes down. That's going to leave us with what? But remember, when you have more than one of a polyatomic ion, which hydroxide for sure is a polyatomic ion, you bring a number bigger than 1 down, you put it in parentheses. We good on that? Yes?
does the number have to be outside of the
It does have to be outside the parentheses. Okay, so let's go over some examples real quick. If you'll write these in your notes, I want you to work on these around your area. If you'll write down these 3, and let's take a couple seconds and work on them, and then we'll check them in just a little while. Okay, so calcium nitrate. We would write this out as Ca, which is 2 plus, and the nitrate is NO3, and it's 1 minus. So we bring our numbers down so that it would read Ca NO3 2. Raise your hand if you got this as the answer. You'll put the NO3 in parentheses. Why? You have them more than one of a polyatomic. It might help if you're starting out with this, if you maybe underline or do some kind of labeling system so that you can identify that this is a polyatomic ion. So is this guy. Here's a polyatomic ion right there, and right there. Maybe some kind of system so that you can identify your polyatomic ions in a fairly quick fashion. Ammonium, what is that? Very good, NH4. What's its charge? What? +1. So it's written right there as a +1. Put that down earlier. And the sulfide, what's its charge? What is it? Nope. It says sulfide. That's sulfite. Sulfide is just a non-metal, right? We went last week and we said that if it's an "ide" ending, it's going to be just a non-metal, right? So that's going to be S, a 2 minus charge. You do crisscross on this and you get NH4 2S. Potassium sulfite. What is potassium?
K.
And what's its charge?
Plus 1. Plus 1.
Sulfite.
SO.
SO3. And what's its charge? -2. So I know that I need to bring my 1 over to the SO3, bring my 2 down to the K, and I would get K2 SO3. Correct?
Yeah.
Why don't I pause real quick? Okay. The strontium is SR. And what's strontium's charge? Okay. Hydroxide, what is that? And what's its charge?
-1.
1 minus. So we bring down our 2 and our 1. Does anyone need to go in parentheses here?
OH.
The hydroxide does, because you're bringing a number bigger than 1, and it is a polyatomic ion. SrOH2. Calcium oxide, do you see a polyatomic ion here?
No.
So now you see that the deck is a little more stacked than it was the other day. The other day you had to be able to notice between ionic and covalent. Not too difficult. Now you need to be able to discern what type of ionic compound you have, which is a little bit more detailed than what we have been doing. Calcium, of course, is 2+. Oxide is O2-. You see no polyatomic ion here because there's nothing from this list. The 2 and the 2, just CaO. Barium phosphate. Ba, what's its charge? 2+. Phosphate. PO4 3-. A polyatomic ion from your chart. Bring down your 2. What has to go in parentheses here? The PO4, right? Why? Because it's a what?
It's more than one.
More than one of a polyatomic ion. Did we put Ba in parentheses?
No.
Because it's not a polyatomic ion. Good? Okay. Now the next thing I want to go over is reversing this, which would be going over the name. But naming polyatomic ions is extraordinarily simple. You name it just like a normal ionic compound. However, you don't change the polyatomic name. There's no "ide." You don't take sulfate or sulfite and make it into an "ide" ending. It's just sulfite. So do we all have these notes right down here? Naming the polyatomic ions are inside of an ionic compound is not a difficult task. You never change the name of a polyatomic ion. Whatever its name is on this sheet, you keep it that way. And then I've listed some examples that you can work out. And all I want from this is the name. I just want to know the name after you write these down. We'll check those in just a couple seconds. CaNO2. What do we get for this one? Calcium nitrate. Very good. CaCl2. Calcium what? Chloride. Was there a polyatomic ion in that one? No. It might help you as before to go through there initially and see your polyatomic ions. I'll label them for you. Every time I see a polyatomic ion, I'm writing Pi. Stands for polyatomic ion. I think that might help you out a little bit. NH4OH. What's that one?
Ammonium hydroxide.
Very good. Ammonium hydroxide. K2SO3. Potassium sulfite. NaC2H3O2.
Sodium acetate.
Very good. And how about the next one?
Strontium cyanide.
Good. Did we get these correct? Awesome. These questions real quick. These are from your homework for this evening. BaCO3, and one thing I might suggest that you're doing early on, as you're starting out with this stuff, is identifying your polyatomic ions that might be there. Now that's not to say that they'll always be there, but in a lot of cases they will be. For instance, there is a polyatomic ion in CO3. The C2H3O2 is a polyatomic ion. Nitrate, sulfate, phosphate. Not all of them, but certainly a lot of them do end in 8, so that's a great way to recognize if you have a polyatomic ion or not. So to me, this is one of the first strategies you would do. As you know, in some compounds, there won't be a polyatomic ion. What's the name of the Ba? What is that?
Barium.
Barium. And what is CO3?
Carbonate.
Carbonate. Come on, guys. He just joined the class 2 days ago. SrC2H3O22.
Strontium acetate.
Very good. Where's everyone else? Diego? Right? Lithium, what's its symbol? Li. What's the charge of lithium? Very good. What's nitrate?
NO3.
NO3. What's its charge?
Negative 1.
Let's move faster. 1 and 1.
Is INO3.
He's right.
Without any parentheses.
What?
Without any parentheses.
That's correct. No parentheses because you didn't bring a number bigger than 1 down. Breslin, what's sodium?
Na.
Na? So, it's all good. We'll just make this a free-for-all, I guess. What is sulfate? It's SO4. It's 2 minus charge. We're bringing down the 1 and the 2 both. So that would leave us with Na2, SO4. Do you see parentheses there? Because we didn't bring a number bigger than 1 after the CO4 or the SO4. Make sure you realize that that parentheses has to occur when you have a number bigger than 1 that is falling after, you put after your polyatomic ion. Potassium phosphate. K is 1 plus. PO4 is what? Keep going. 3 minus. We're bringing down the 3 and the 1. Are we going to use parentheses on this example? This is just going to be K3PO4. So with today's lesson and this homework, which of course is going to be due tomorrow first thing, you are seeing our special case number 1. There's 2 special cases of ionic compounds. This was case 1, as I mentioned in the notes. That first additional concept in which you have ionic compounds with polyatomic ions. Tomorrow, I will go over additional concept number 2. Good?